Good afternoon, everybody. Today's lecture will be on transformation of mechanical energy. We will focus our attention on kinetic energy, and potential energy. And we will specifically look at gravitational potential energy. Okay, we need to define these first when we look at the transformation of these energies. Kinetic energy is energy of motion. It is after the Greek word kinetos, and kinetic energy has K equals 1/2 mass times the square of the velocity. So when some mass is moving with a certain velocity, you have a kinetic energy. The gravitational potential energy and I will abbreviate with PE, we use the letter U sub G, that is mass times the gravitational constant times the height of the object. When we look at these different energies, I will do a simple demonstration that shows a simple transformation, and then we will discuss the energies of these transformations. So I'll now go to the apparatus. If I hold this ball up a height h above the starting point, it now has gravitational potential energy with respect to the table. It is at rest, it has no kinetic energy. When I let go, its velocity increased downward, so the moment before it struck the table, it had the maximum kinetic energy. Let's look at what happened. I will drop it one more time. And now let's look at what's happening with the physics. So in this example, we dropped a ball. We have a starting height of height h above the zero reference. So if I take and make another copy of the ball, at this moment it has no kinetic energy, all gravitational potential energy, and as it falls, now you can see that we have both kinetic energy and gravitational potential energy, but you notice that kinetic energy is increasing at the expense of gravitational potential energy. And at the moment before it strikes the table, it is going to have all kinetic energy and no gravitational potential energy. So this is the transformation of mechanical energy from kinetic energy, from gravitational potential energy into kinetic. So we have a transformation of pure gravitational potential energy into kinetic energy. Let us look at another demonstration of this transformation. In the second demonstration, we have a roller coaster, and the roller coaster will start up from the left, make a slight dip, go over, back, and back up. A golf ball will be rolled on this roller coaster, So that's what I went to next. Starting here, we have purely gravitational potential energy with respect to the bottom of the track on the table. And let's look at what happens. The ball rolled. Here it started with gravitational potential energy. It transformed into kinetic, but note we still have some gravitational potential energy yet and kinetic combined. We lose some of the kinetic energy to increase our gravitational potential energy. Then the gravitational potential energy goes down to the maximum possible value of kinetic energy. And over here, we will lose kinetic energy and gain gravitational potential energy. Let's try this one more time. So with the demonstration, you can see the transformation of mechanical energy. Here we have pure gravitational potential energy. Then when the ball is down in this first little dip, we have both kinetic energy. The kinetic energy is fairly high there, but we also have gravitational potential energy. When the ball goes on the top of that little bump, we have kinetic energy and gravitational potential, but the kinetic energy was reduced some with the gain in the gravitational potential energy. When the ball reaches the very bottom of this dip, second dip over here, we have the maximum kinetic energy possible, and we have zero gravitational potential energy. And finally, just as we are leaping off of this track with this ball, we have kinetic energy and gravitational potential energy. Is there any questions? Thank you very much.